In this video, I'm going to explain some of the experiments there in electronics principle and circuits. The first experiment is design and test bridge rectifier with capacitor input filter. So this we are going to simulate using multisim tool. So you can refer my previous video how to install multisim 14.2 student version. So in this how to simulate this electronic circuit simulation. I'll explain. The first experiment is to design and verify bridge rectifier with capacitor input filter. So the theory part is this. So in order to uh, simulate this, we have to place some of the components in the multisim tool. We have to pick one transformer, step down transformer, and one AC source, and one bridge, and one. First, we'll explain without filter what is the output. After that, we'll also add capacitor filter and we'll verify how in the output the ripple content is reduced. So let me explain the theory part. Here step down transformer will reduce the voltage by 10 times. Okay, it is the number of turns ratio is 10 is to 1. Suppose it is 240 volts, it will reduce to 24 volts. So after that, if I give it to the bridge, see the bridge here, this is a D1, D2, D3, D4. So in the positive of cycle, this point is positive with respect to this point. So diode D1, this diode and this opposite diode. This diode and another, this diode is forward bias and opposite, these two diodes are reverse bias. So this acts as short circuit. These two acts as open circuit. So current flows through this path. Okay. And in the negative of cycle, okay, point B, this point is positive, this is negative. So what happens? This is connected to the positive here. This is forward bias and this is also forward bias. Now these two diodes are reverse bias. So this acts as a short circuit. These two acts as open circuit. Now current flows from plus will go here. It will go to the load and again it will come here. Again it will go to here. Okay. So this is a full wave rectifier where both positive off cycle and negative cycles are going to rectify. So this is called as bridge rectifier because we are using bridge instead of in the off wave rectifier we are using single diode. In the center tap type we are using two diodes, but in the bridge rectifier we are using bridge component. So let us simulate this. This is last oscilloscope, the capacitor. This is a load resistance RL. This is a ground symbol. So I'm opening multi-sim tool. So I'm going to rig up this circuit once again. Go to file, new, blank component here. So now if you want you can zoom it. Okay, now we will place one by one now. Okay. So first see, you have to get one AC source, one transformer, one bridge, and one resistor I will place. So one by one we will do now. Go to place component. Okay, when you open the multi-sim tool, you will get place tab is there, place component, or you can press Control W. You can see here the shortcut keys are you can see the right side here. Control W. You can press Control and W button in the keyboard, or you can press click on place and component. You will get like this. So now I want to place sources now. So there is a all groups and all families. So here in the groups I'm selecting sources, and after that you click on power sources. Okay, in the power source what are available you can see in the here. AC power is available, DC power is available, ground is available, are related to power sources. So next tab is what single voltage sources, uh, single current sources, controlled voltage sources and all that. Now I want only power sources. You have to select and AC power. Now click OK. Okay, this is a selected one. Now you have to place here. So by default 120 volts RMS value is there. If you want, you can double click and change the value to 240 volts and 50 hertz, or let it be 120 volts RMS value only. So next, what you have to place? You have to place one transformer. So you can go to all groups, all families. You just type one primary, one S. So one P, one S you type there. You'll get that is one P means one primary winding and one secondary winding. You'll get this. This you have to click OK and place here. After that, we want one bridge. So bridge is available here in the diodes. Go to the diodes block. All groups, in the all groups you have sources is there, basic is there, transducer is there, analog is there, CMOS is there. You go to the diodes. In the diode, you can see here FWB. Okay, FWB is full of bridges only. Okay, full wave bridge. Okay, full wave. You can see all are bridges only. All are different types bridges. So you can select any one. I am selecting the first one. 1B. Okay, one bridge. So four diodes are there. Click OK. Otherwise, you have to select four diodes and you have to arrange according to this. So that is difficult. So ready-made bridge is available. You can pick and place that. After that one, I want one RL. So that is there in the basic. In the basic, you select resistor. By default, 1K is selected. If you want, you can change. So now I want to place resistor vertically. So you have to press Control R button. If I click Control R button, you can connect here. And I want to have one ground also. So that is there in the sources. Go to group. In the group, you select sources. In the source power source block, we have ground, digital ground. D ground means digital ground. For digital circuits, we use this. For analog circuits, we use this symbol. This is a symbol of ground. So I think we need. Mm, let me place one or two. If it is not required, let us later we can delete it. Okay. So let me check how many is required. Only one is sufficient. Okay. Now to make the connection, always you have to start at the edge of this corner. Okay. So click on that again, click and go left, click and come down. Again, click here, click once again, go right side, click, go up side. Okay. Primary side connection is over. Primary winding connected to VAC, that is 120 volts RMS AC voltage is connected. Now in the secondary windings, it should be connected to this and click on here, click and go right side. If you get like this and all, okay, click and go here. So you can click and drag this. So now opposite sides, this top and bottom edges, corners, they are connected to primary winding. In between these two, we have to connect load. Okay, in this and this, we have to connect load. So click here, go right side, click and come down. Again, click and now you should have to connect to here. Click here. Don't stop at this vertical line. If any dot comes here, then there is a connection. Here there is no dot. Okay. If you stop here, one connection will come. I will show once again. You select that and delete it. I'll show if you make a mistake, you will not get output. If I see here, now this is wrong connection. Load should be connected between this end and this end. So don't stop at this point. You select this and delete, click delete button. So what you have to do, otherwise you come like this. click escape button. I will place this one here. Click here and go upside. Okay, there should not be any connection here. They should not come dot here. Okay, so now this is over. Or again, if you want, you can drag this down. That is left to you. Okay, how you are going to connect. Control Z means undo. Okay, now you have to connect this ground here. So I cannot start from here. See here, I want to make connection to this. I cannot start from here. I told no, always you can do connection starting from edge of the component. So from this, I cannot start any wire, but here I can start. Okay, so now connection is over. Now I want to see the waveform. For that, I need one output device. So right side, go to the right side of multisim tool. So there are components, multimeter is there, function generator is there, wattmeter is there, oscilloscope. Select oscilloscope. There are 4 channel is also there, 2 channel is also there. 2 channel one I selected and I placed here. So channel A and channel B, and this is the symbol of oscilloscope. So I am connecting, this is positive, this is negative. So I am connecting one to load RL. Okay, this should be grounded. You can have one more this ground and you can connect here only. Okay, you can have one more ground symbol here only and you can connect, or otherwise you can bring this connection to here. So we connected this to this ground only, or you can connect here also wherever red color is there. No, you can connect, and wherever connection is there, that symbol will come, this dot. So connection is there. So now we are connected. We are seeing only output across this, but one more channel is there. Through this we can see the input waveform also. Input means primary side winding. So this you have to connect. Click here, come down. Okay, and you connect here. This click here, come left and connect here. See wherever connection is there, this dot will come. See in the channel B, I connected input. In the channel A, I connected this. And if you want to differentiate the color in the CRO output scope, you can right click on that, right click segment color, you can change, so that for input I am giving blue color. Okay, input signal I am watching through blue color. Okay, and output I am giving another color. So let me give green color. Output is green color, input is blue color. So in the CRO, if I double click, we can identify which one is input, which one is output. So now according to this color segment I had given, blue color is for input, green color is for output. Now everything is over. Now we have to save this file. So we can save this file as bridge rectifier now. So I can give the name as bridge rectifier. Now I have not connected any capacitor filter. Let us see what is the output without filter. So now you have to, if any previous program is running, you have to stop it. Okay. First, if it is runs, if run is not green here, that means any previous circuit is already running. You have to see if any program is running, you have to stop it, and or better you close all the previous program and keep only one program on the screen. Now red color, this green color run button is enabled. You can go to simulate and run. If it is not enabled, definitely another circuit is running. You have to stop. You have to identify where the circuit. Here I had 5 taps. Okay, so one circuit was running. That's why that was not enabled. Now I can enable and I can run this circuit. Okay. Okay. Now let me run this program. This is a run button. You can, two ways are there. One, click simulate, run button, or you can also press F5 button in the computer, or you can directly in the here red color, green color button is there, you can click. Okay, now what is the voltage here? RMS value is 120. It is reduced by 10, 10 is to 1. So 120 is stepped down by 10 times. So you are going to get 12 volts RMS value here. The 12 volts RMS is connected to bridge. So after that, in the forward bias, in the positive of cycle, this diode, right side and opposite to that, these two diodes are forward bias, acts as a short circuit. These two, reverse bias, open acts as open circuit. So current direction is in the positive of cycle, current goes like this. It will go to the RL, it will come down. Again, it will go to here. Again, it will come down, and again it will go to here. So there is a complete path. These two diodes are reverse bias. Now, in the negative of cycle, this edge, this point B is positive, this is negative. So this is connected to the P side of the diode is connected to this. So this diode is forward bias. Okay, and this is forward bias. These two opposite diodes are same always. These two are forward bias. Now these two are reverse bias. So current direction is it will go like this. Again in the second half cycle also current goes down only. Current goes down only. So output becomes same direction only, and it will go like this. See the mouse pointer. This is in. So now it is running now actually. Now to check the output, you have to double click on this oscilloscope. I'm double clicking on this. See now you can drag like this. See input and output are coming in different colors. Now I will click on single button here. Sometimes it will stop. Now it is not stopping. So let it be auto only. So this is a scale in oscilloscope. Each box how many divisions? Okay, this is time division, time base. This is channel A. Okay, channel A is this, channel B is this. So I'm clicking 10. Okay, one box means 10 division. One division is equal to 10 volts. Okay, so how much it is coming? Let us see now. So here 0 means channels are grounded. Okay, if you want to see AC, you have to click AC. DC means this one. So input should be AC. Input is connected to where you see here. Please see here. Input is connected to what? Channel A is connected to output. So channel A should be DC. Okay, channel A should be DC. Okay, channel B. Channel B is connected to input, primary side. That means this is a rectifier which converts AC to pulsating DC. So I want to see input AC. So input this channel B should be AC. Okay, and if you want to stop, you can ground. If I don't want to see the input, ground this. See now I am seeing only output. Okay, this is the output. Negative cycles are coming. If I want to see only input, you ground channel A. 0 means ground. See this is the input. Input is full, it's coming. If I send this one to bridge rectifier, okay, rectifiers converts AC to DC. Actually we want straight line, but we are getting pulsating DC. That output should be DC. Output should be DC. Now AC input I am grounding. See the output is negative cycles are all removed. So positive cycle is coming positive, negative cycle also rectified and it is coming. So this is the output without capacitor filter. Now let me add capacitor filter to stop the program. Okay, now I'm going to place one capacitor here. So to place the capacitor, stop the program, then go to place component, go to basics, and in the basic capacitor will be there. Select this will come by default 1 microfarad is selected. So you select some 470 microfarad. You select that one also and you can rename it, no problem. 470 microfarad I want. Okay, let me click this one only, no problem. After that, we'll double click and you can change it. So how to rotate? Control R button. Now if I place this, see 1 microfarad is came by default. Okay. So if I want to change the value of any resistors or something, you just double click on that component. There is a value. That value you have to change to desired value. So in the value, what is there? 1U. Micro, it's coming as U only. So double click and you there and go to value. Change it to one value to 470 U. U means micro. So you can see it is coming as 470 microfarad. You can place like this anywhere. Always capacitor across the load. I'm connecting the capacitor filter. So I cannot start from here. See here, I cannot start from here, but I can start from here. See dot is coming here. That means I can make the connection, but here there is no dots coming. So go to here, join here. Go to this side. You cannot start from here. You have to go here and you have to stop it. Now capacitor is connected across this. Now once you connect capacitor, first capacitor will charge, next it will discharge, charge, discharge, charge, discharge. Instead of this waveform, this is ripple content. DC means what? Straight line. Okay, instead of this is an unwanted AC present in the output, we call it as a ripple content. So using capacitor filter, we are removing this ripple this is a ripple content we are removing. So output can be straight line only you are going to get. Let me check the output now. So once again, start simulation. See here, output is coming. Previous output was like this, right? Now it is coming almost like this. Now if I want to see the input also, remove that give AC. See, input is this. Input is green color. Okay, input is green color. Sorry, blue color is input, green color is output. No, okay, it is converting AC into DC, and you can observe actually output is little bit less than the peak because two diodes are connecting at a time now. So each diode will consume some 0.6, so that much voltage is reduced. Okay, so what is the DC voltage you are going to get here? That you can check it out. Channel B is output. Channel B is green color. So channel A, in the channel A, so let me ground this. In the channel A, what is the output you're getting? Approximately 15 volts you're getting. You're going to get 15 volts. Let me check in the calculator whether the answer is correct or not. Okay, calculator. Okay. Here, so it is Vm by 2 Vm by pi, I think. Okay, let us verify our answer or not. So, what is RMS value? RMS value is 120, that is reduced to 12 volts. 12 volts is the RMS value. Peak value is into root 2. Okay, so it is 16.97. Okay, this is Vm maximum value. And Vm by pi, let me check. Okay, this is 5.4 into 2 Vm by pi. I think it is the answer. 10.8 you should get. That is the case in case of without filter. Okay, the without filter, that is the output. But in with the capacitor filter, now it is coming almost 15.1. Okay, for with filter, how to find a DC value, different formula is there. So you have to take a VM. From the VM, you have to take ripple voltage peak to peak value divided by 2. Okay. So now actually DC is actually better than the without capacitor filter. So leave it this part. So you observe now only this much. Okay. Input is this. Okay. It is coming almost to peak value and you are not getting this much, little bit less you are going to get. So we are converted AC to DC. So what is the aim of the experiment? Without capacitor filter, we got more ripple content output. So output is coming, going up and down, up and down. So that is a ripple, that is unwanted AC present in the DC. So we use a capacitor. So now that unwanted AC is removed, output is coming almost straight line like DC waveform. Okay, thank you.